All right, today we got enough people that are going to be in and out throughout the class period, so I'm just going to post a video. That way we can all be on the same page, even if you're not physically in class today. First two slides are going to be your warm-up today. So if you're watching this online, please, I do recommend that you actually try these before just taking notes and trying that. You hit that little pause button there in the corner, and you should be able to work these out and then keep going, and you can have as much time as you need and keep working through these. The first one, we're going to solve this algebraically. We're going to use either one of those two methods that we talked about yesterday in class, substitution or elimination. If I look at this first equation here, it would be really easy to solve for x because x is by itself. So I don't use substitution a lot, but because this is set up so nicely for us to use substitution, I'm going to go with that. It works the same way if you're going to use elimination. But if we add 2y to both sides, we get that x is equal to 2y plus 3, or 3 plus 2y. Doesn't really matter. Then we take this, we plug this in here, and we're going to get 2 times 2y plus 3 minus 4y is equal to 7. And now we're back to our nice algebra equations from Algebra 1. And we distribute here, we get 4y plus 6 minus 4y is equal to 7. Combine my like terms, and I take 4y minus 4y, and that just happens to cancel out. So I'm left with the expression that 6 is equal to 7, which hopefully you guys are looking at this saying, well, that's not true. This is not a true statement. 6 is not equal to 7. 6 is equal to 6, and 7 is equal to 7. When you get this, and it's an untrue statement, it is never true, no matter what x and y are, you get some statement where 6 is equal to 7, or 0 is equal to 3. That's okay. That would work. You can get those. Those are what our no solutions are going to look like. You're going to get that always false statement. Remember from our graphs, those are those parallel lines. They're never going to intersect. Okay. We'll try another one. This one. I look, and right away, I don't see x or y by itself. So I don't just have an x or just have a y. So it's not very easy to solve for either one of them. But I do know what I can do is 6 and negative 15 both go into a certain number. So I can use my elimination method. This is kind of my go-to just because I like to multiply and then add and just have a smaller equation to plug into. And there's less, I think there's a few less steps in there than if we use the substitution method. So if I multiply my top equation by 5, I'm going to get that 30x minus 50y. Remember that 5 gets distributed to the 6, the negative 10, and the 12. So I'm going to get 50y, and that's going to be equal to 60. And now I got to try and get my x or my y's to match up nicely. So since I already have a negative 15x, I know that goes into 30 twice. So again, I multiply this entire equation by 2, and I get that negative 30x plus 50y is equal to negative 60. Now that we have the same numbers but different signs in front of our x's, I can go ahead and add. So I'm going to get 0x plus, well, negative 50y plus 50y is going to give me 0y, which is going to be equal to 0. So 0x and 0y, doesn't matter what x and y are, you're going to end up with 0 plus 0. So you're going to get 0. You're going to get 0 is equal to 0. Now this is a true statement. No matter what, 0 is equal to 0. It does not depend on x or y. So what we have going here is we've got an always true statement. This is what our infinite solutions or the all real numbers double bar are that we talked about before, where we've got those two lines that are stacked on top of each other. So if it's always false, you're going to have your no solution. Always true, then you're going to get your all real numbers. A little bit of a story problem here for you guys. A caterer is planning a party for 64 people. The customer has $150 to spend. A $39 pan of pasta feeds 14 people, and a $12 sandwich tray feeds 6 people. How many pans of pasta and how many sandwich trays should the caterer make? Again, with these, I like to always know what you're going to define your variables are. Typically, most people go with X and Y. This one you could do like P for pasta and S for sandwiches. I'm going to avoid that because my S's tend to look like 5s, and that's going to make me make a mistake, and we don't want that. So I'm going to let X equal the number of pasta pans. And I'm going to let Y be my number of sandwiches. Now I need to make two equations. One is going to deal with my cost, and one's going to have to deal with how many people I can serve, because they tell me in the problem I got to serve 64 people. Also tells me that I have $150 to spend. So my first equation, I'm going to look strictly at cost. Tells me that $39 is the cost for a pan of pasta. So I'm going to take 39 times however many pans of pasta that I get, call that X. And then I'm going to add on to that my sandwich trays. But I've got $12 per sandwich tray, so I'm going to take 12 times however many trays I get of sandwiches, and together that has to be $150 because that's all the money that we have to spend. Now, we're going to look at strictly people. Well, a pan of pasta feeds 14 people, so I'm going to take 14 people times however many pasta pans that I have. That's going to give me how many people eat pasta. And again, I'm going to add on the people that are going to eat sandwiches, which each sandwich tray feeds 6 people. So I'm going to take 6 times the number of sandwich trays that I have. That's how many people are going to eat those. And that has to be equal to the 64 people that we need to serve. We need to go ahead and use one of our methods. I don't really care which one you use. They'll both work. I think in this case, elimination would be a little easier. I just multiply this bottom equation by -2 so that I can eliminate my y's. So my bottom equation becomes negative 28x minus 12y is equal to negative 128. And just to make this a little easier, I'm just going to copy my top equation down just so I have those right next to each other, make that addition a little easier. So I end up with 39x plus 12y equals 150. And now I'm off to the races. I can start adding. I'm going to get 11x is equal to 22. Those y's are gone. Again, divide by 2, or divide by 11. Sorry, getting ahead of myself. Divide by 11. And I'm going to get that x is equal to 2. Now, I need to use that, and I need to figure out how many sandwich trays I need to order. So I'm going to take this 2. I'm going to plug it into another one of my equations. It doesn't matter which one you use. I'm going to use the green one just because they have a little smaller numbers, so makes my math maybe a little easier. I can do a little more with my mental math. So I'm going to take 14 times 2 plus 6y equals 64. Multiply that out, I get 28 plus 6y equals 64. And subtract 28 from both sides. I get that 6y is equal to 36. Divide both sides by 6. I get that y is going to be 6. Now, before, it's been completely where those two lines are going to intersect. What we're going to do today is now we're giving that application. So x being 2 means that I need 2 pans of pasta. And I need 6 sandwich trays. So this is when we can get away from those ordered pairs, because now they have context. You can tell me exactly how many of each I'm going to need. So I'm okay with that not being in an ordered pair. All right, here's your homework. It's also posted on my website. If you're reading this, then, or if you're watching this, you've obviously found my website. So it's under lesson plans. If you have any questions, come see me. I'll be happy to walk through these with you, talk through things with you, clear things up, whatever you need. And I will see you guys in class tomorrow.